Hi, welcome to Unit 2, Topic 1, Video 13, and here we are with the proofs, starting of course with the sine rule. Okay, now we're on to our optional video, the proofs of the sine and the cosine rule. You don't really need to know this, but you might be interested. If it doesn't make sense, it's probably not worth stressing about it too much, but you are more than welcome obviously to ask the questions you need to ask. So the easiest way to do a proof is to start with a good diagram with all of our variables in it. So my diagram is going to be this one here, and I'm going to label it A, B, C, and therefore it's A, B, C. And I want to start by proving the sine rule. The sine rule is going to come from some information that comes from this nice diagram here. So I'm going to call this guy the height. Now, there's a few things I know about this diagram. First of all, I know, one, that sine of A is equal to height over B. And I also know, two, that sine of B is equal to height over A. So I'm just, tracking straight across here, just those opposite values. And I've built a little right angle triangle here. So it's just right angle trig to set those up. Now, equation 1 leads me to, if I multiply it out, height is equal to B sine A. And equation 2, if I multiply it out, height is equal to A sine B. Okay, now this is good because that can now be eliminated or use the substitution. So this is now, we're now going along the simultaneous equation line in a sense. So if h is equal to this stuff and h is equal to this stuff, then naturally B sine A must be equal to A sine B. They must be equal. And so then if I divide through by B, I get sine A is equal to A sine B over B. And then if I divide through by A, I get sine A over A is equal to sine B over B. Hip hip hooray! So there's our proof of the sine rule. We can extend it to C as well if we wanted to. Have to drop a perpendicular there or there, but we don't need to. That's our proof, that's where it stems from. Okay, so I'm going to rub this off and we'll have a look at the cosine rule. And now we have the proof of the cosine rule. Okay, thanks for that. I've changed, same diagram, changed a little bit around to make things easier, and I've rubbed it off. So let's move forward. Cosine rule comes from these facts. It's a little bit trickier than a sine rule, but let's build some stuff up. So first of all, it involves cos C. So let's start with cos C equals, in this right angle triangle here, adjacent over B. So we're going to introduce another value here, and that will be x. And that means that this is now A minus x. So that'll be important later on. So cos C is equal to x over B. And so therefore x equals B cos C. That'll be important later on. So we'll call this equation number 1 to help us just name things. And I've also now got some Pythagorean relationships I can identify. So the first one is x squared plus h squared is equal to B squared, call this equation number 2, and I'm actually going to take the x out now and put B cos C in there, am I? No, I'm not going to do that. So let's get the second one, A minus x squared plus h squared equals C squared. That comes from this one, and we'll call this equation number 3. Now I want to eliminate that h, so in equation number 2, I'm going to rewrite it as h squared equals b squared minus x squared. And then I'm going to sub into equation number 3, and that will give me not enough room, so my equal sign is going to move across. No, maybe I'll do it down here. A minus x squared plus b squared minus x squared equals c squared. Now I'm going to expand this bracket here. Take your time if you need to. I'll do it over here quickly. A minus x squared is equal to a squared minus ax minus ax plus x squared, because a negative times a negative is a positive, a squared minus 2ax plus x squared. So I get a squared minus 2ax plus x squared plus b squared minus x squared equals c squared. The x squareds cancel out, hip hip hooray, and that gives me a squared plus b squared minus 2ax equals c squared. But remember, in 1, x is equal to b cos c. So I get a squared plus b squared minus 2a b cos c equals c squared. I flip it around, c squared is equal to a squared plus b squared minus 2ab cos c. So that's where that's come from, if you're interested, and obviously you can rotate this around and relabel it and come up with the versions with cos A and cos B if you need to. There we have it, the proofs as an optional video. All the best. Well, it's been great having you as part of this 13 video series on the applications of trigonometry, Unit 2, Topic 1. If you've got any questions, make sure you ask and go back and review the videos as you need to. Remember, this video was optional. All the best.